In this lesson, we'll be talking about predictions from a trend line. By the end of the lesson, you should be able to create a trend line to make predictions and write an equation for the line of best fit and use it to find other solutions. So a trend line or best fit line shows a pattern in the data, and we use this to make predictions. So for example, we have this scatter plot, and it says predict the value of y when x equals 5. So we draw a best fit line, and then when x is 5, so we go to x at 5, and we go up to the blue line and over y is 7. So when we're drawing a trend line, it tells us when the scatter plot is positive or negative association, or if there's no correlation at all. So when you're making a trend line from a scatter plot, you never want to connect the dots. You want to make a straight line. And so when you make this straight line here, we can see that this has a positive trend. Over here, we can see that this straight line has a negative trend. And in this one, there's no trend. We can't make a line either direction. So for example, find the equation of a trend line for the given pair of points, and then use the equation to predict the y value for the given x value. So when we're looking for slope and we're given points, remember it's y2 minus y1 over x2 minus x1. So 15 minus 1 over 24 minus 3. 15 minus 1 is 14, 24 minus 3 is 21, and that simplifies to 2/3. And then you're given that the b is -1, so that's our y-intercept. So we can go ahead and write the equation. Y equals 2/3 x minus 1. And then it says predict y if x equals 15. So that just simply means that we substitute for x, we put in 15. So then we multiply. 2/3 times 15 is 10. Then minus 1. 10 minus 1 is 9. So write an equation and make a prediction. So in this first example, we want to write our equation. So we know that we need the slope and we need the y-intercept. So the slope, we'll pick 2 points on the line, so you can see these points are a little bit bigger just so that you know those are the easiest ones to use. And we count up and over, so that's up 20 over 100. 20 over 100 simplifies to 1/5, and then our y-intercept here is at 0. Then we just substitute 300 for the x, or we just go to 300, and we go up to the red line and then over to 45. In the next one, again, we've got the 2 dots that are just a little bit bigger. That shows that they're the easiest ones to use. So we'll use those to find our slope. Up 9, right 1. So our equation is y equals 9x. And again, our intercept is 0. At 30 miles, we can plug it in, or we can just go over here at 30 miles and then come down and get 3.5. In this third one, we're looking for our slope, so we use the 2 points there, and it's up 8 over 12, so that simplifies to 2/3. To find it at 40 minutes, we just go here at 40 minutes, up to the line, and go over to 28. All right, so this time we're looking at this graph, and we've got the bicyclist distance versus time. So the first question says, is this graph linear? Well, since I can make a straight line, I'm going to say yes, it is linear. What is the correlation? Well, they're pretty close. We can definitely see a pattern. It's not exact, but it is close, and it is negative. Describe the graph. Well, remember we describe it as x is getting bigger, so as we go this way on the x, the y is getting smaller. So as time increases, distance decreases. Are there any outliers? Well, it looks like yes, there's one up here, and that is at 6/200. What is the approximate correlation coefficient? So again, we can see a pattern. They're not super close, but it is negative, so we'll go with -0.7. What is the approximate y-intercept? So we'll go up here to where the Y crosses, and it looks like it's about 170. What is the slope of the trend line? We're going to use these points that look like they're a little bit darker. And it looks like it's going down 100 and over 4. So that simplifies to negative 25. What is the equation of the best fit line? Well, now we have the slope and we have the y-intercept. So it's y equals negative 25x plus 170. If the bicyclist has 80 kilometers remaining, about how many hours has passed? So we'll go over here to, he's got 80 kilometers left, and we'll follow that over to the red line and down, so about 3.5 hours. If the bicyclist traveled 3 hours, how many kilometers are remaining? So we'll travel here from the 3 up to the red line and over to 100. Can a trend line always be drawn? No, if there's no correlation, we're not going to be able to draw a trend line. So what are the 3 types of correlation? Positive, negative, and none.